Okay, so we are starting exponents. What we're learning today is not new. So exponent rules. So just really to start, the big part, so if you have like an x squared, x would be your big part, that's your base. Okay, the little part, the 2, would be your exponent. Okay, so we're going to talk a lot about like what exponents actually mean. So what do exponents actually represent? What do exponents tell you to do? Like when this says 5 to the 6th power, what is that telling me to do?
How much to multiply by times 5?
It's saying 5 6 times, right? So this is the same thing as saying 5 times 5 times 5 times 5 times 5 times 5, right? Okay, now obviously which one's the easier one to do? The first one. So we can come in our calculator. Do y'all know how to type anything other than squared? This little carrot top thing here, the little arrow up. Okay, you'll click that, and then you can type a 6. Press enter, and you get this. Now, also to show you 1, 2, 3, 4, 5, 6 gives you the exact same thing. Okay, so we get 15,625. Okay, on example 2, parentheses are super important, especially when there's negatives, because I'm going to show you. So here we get this, which is 81. And now watch what happens if I were to type it without the parentheses. It gives me negative 81. Definitely not the same thing. I'd rather have a positive $81 than a negative $81. Okay, the reason being is your calculator follows PEMDAS, and it does exponents, and it thinks of the negative as multiplication. So you have to, for it to think of this as a negative 3, you have to use parentheses. It's weird, but it is what it is, okay? So just make sure that if you're finding the power of something that's negative, make sure you use parentheses, yes? Cool. Okay, here. What should you do first? Should you multiply 4 times 3 or do 3 squared?
3 squared.
3 squared, because PEMDAS, parentheses, exponents, multiplication, division, okay? So what is 3 squared?
9.
And what's 4 times 9? Yeah. Now, could we have just typed that in the calculator just the way we saw it? 4 times 3 squared? Yes, we could. And it gave us the exact same thing. So what do we get on example 4? 3 times 25, which is what? If I can write a 5, it does. It equals 75. Any questions with those? Okay, the best part about all of these are calculator problems, even 5 and 6. So 5 and 6 do give us a variable, but doesn't it also tell us what that variable is? So it tells us 2x cubed, x is 5. So can I rewrite it without a variable? Yeah, I can rewrite it as 2 parentheses 5 to the 3rd power. So again, what am I going to do first? 2 times 5 or 5 to the 3rd power? 5 to the 3rd power. Now, I'm going to just type this in my calculator, but if we were doing it by hand, we would definitely do 5 to the 3rd power first. So 250. Okay, so I want y'all to try number 6 on your own. What do y'all get? 1. Did anybody get negative 1? No? Okay, so I've had a couple people today tell me negative 1, and it's because they forgot to use parentheses. If you plug in a negative exponent without parentheses, it's not going to recognize a negative number, okay? So make sure you use parentheses. Any questions with those? We like those, okay? Okay, let's look at, now we're going to start looking at the rules. Okay, a couple of the rules are super simple. A couple of them get a little complex, and then we're going to start looking at the rules together. None of today is super hard. Y'all have done this before, I promise, okay? So power of 1. Power of 1 is super simple. A to the 1st power is just A. It's almost like saying 1x is just x, same concept. Okay, and the reason we have to think about things like this, you'll see in a minute, But it's just so you can say x is the same thing as like x to the first power. Or c is the same thing as c to the first power. Or this whole thing to the first power is the same thing as just itself. Okay, super simple rule, almost like not even really a rule. You just need to understand that if there's no power, it technically has a 1. Okay. Now, what about power of a 0? Do any of y'all remember what anything to the 0 power equals? Not 0. 1. Anything to the power of 0 equals 1. And you can even like test that. You can type some crazy big number and put it to the 0 power and it equals 1. Okay? Same with letters. You can put letters, and you can't type letters in your home screen, but you can put letters, anything to the power of 0 is 1. Okay, so here, this whole thing is to the 0 power, so what does that whole thing equal?
1.
1. Now, what about number 9? 2. Look at y'all go. Okay, m to the 0 is 1. Plus n to the 0 is 1, and 1 plus 1 is 2. We used to put a problem like that on a quiz or something, and people always were like, look at y'all go. So smart. Okay, the next one says product of bases. What does product mean?
Total.
When you multiply. So it's your answer when you multiply. Okay, and I'm going to actually do an example, and I'm going to have y'all tell me the rule. So if I have m to the 3rd power times m to the 4th power. So watch, I'm going to write it out. So m to the 3rd power is m, 2, 3 times m to the 4th power. 1, 2, 3, 4. Well, how many times did we just multiply m? 7. How could I have gotten there quicker with just these two? 4 plus 3. We could have just added the exponents. That is the rule. It's just adding exponents. And the reason being is because you're just saying, well, look, if I add it 3 times and then I multiply. If I multiplied 3 times and then I multiply it 4 more times, I multiplied it a total of 7 times. It's just because you're finding the total number of multiplication. Okay, so you just add your exponents when you're multiplying and the bases are the same. Okay, so here, this one is throwing a coefficient in there. If I put a 1 up here, the big numbers, coefficients up front, we treat them like normal. So this says multiply, guess what we're going to do? We're going to multiply. What's 1 times 2? Now, then I have m for my base, and I have m to the 5th power times m to the 4th power. How many times did I multiply m?
9.
There you go. Mm-hmm. 5 plus 4. Because if I multiply it 5 times and then I multiply it 4 more times, that's a total of 9 times, right? Okay, and over here it says order to write answers. It's your number, your coefficient, then your variables in alphabetical order. Okay, so just know your proper way to do it is always to put your letters in alphabetical order when you have more than one letter. So here, again, we have coefficients. What's negative 3 times 4?
Negative 12?
Mm-hmm. Negative 12. Now, how many times are we multiplying C? And then, so, together? No? 4.
You always add the exponent?
Mm-hmm. And remember, power of 1 rule, if this is C, it's the same thing as C to the 1st power, right? So if this is just D, this is the same thing as D to the 1st power. So how many times am I multiplying D?
D5?
Yep. So that's why the power of 1 rule is there. Okay, I want y'all to try number 12 while I take attendance. Okay, so what do we get?
Negative 8.
-8.
A4.
A4.
C5.
C5.
D.
D. Any questions with that?
Did you put a 1?
Like this? No, that's totally fine. Yeah. And that goes with that first rule we talked about, power of 1. Same thing. Any questions with those 3 rules? Okay, cool. Let's keep going. So now we have quotient of bases. So quotient means divide. I know it's a weird word. I feel like it throws a lot of people off the word quotient. Okay, so when we did multiplication, we added our exponents. So what do you think we're going to do when we divide? Subtract. Huh? Okay, but I'm actually going to write these problems out, and you'll see why in a minute. Okay, so yes, we subtract, but I'm going to show you why. So I'm going to write 11x is 1, 2, 3, 4, 5, 6, 7. 11 over 5, 1, 2, 3. Okay, when you divide, anything divided by itself does what? Turns into 1. It pretty much cancels, right? So this cancels, this cancels, this cancels. That technically those all turned into 1. And 1 times 1 times 1 times 1 is 5. I mean times 1 is 1. Don't listen to me. Okay. And we don't have to put the 1 in front. How many x's do I have left? 6. So I have x to the 6th power. And again, like I said, we didn't have to put the 1 in front. Now, do we have to have a denominator? Does everything have to be a fraction? No, so we're done. There's nothing left in the denominator. The fraction canceled. There's my answer. Well, what's 11 minus 5? 6. So could we have just gotten that by subtracting? Yes. Okay, but the reason I wanted to show y'all working it out is you'll see why on this one. So when we have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So again, we're going to cancel as many as we can. So 1, 2, 3, 4, 5, 6, 7, 9. We canceled 9 of them. And how many do we have left? But where are they?
On the bottom.
On the bottom. And can I just move them to the top? No, because 1/3 is not the same thing as 3. Okay, if I have $3, that's not the same thing as having 33 cents. Okay, it's not the same thing. So I have to leave into the 3rd power on the bottom because that's where there were more ends, right? Now, can the top be empty?
No.
So what do I have to put there? A 1. When I canceled all these, doesn't that all equal 1? Yeah, 1 times 1 times 1 times 1 is just 1, so we can put a 1 on top. It doesn't change anything. So we'll get there in just a second, but it wouldn't be a fraction anymore. If we were to do that, you would have n to the -3 like this, but this is the proper answer, and when we get to the negative exponent rule, you'll see why. Okay, so only 2 more rules, and I'm actually not going to do all of these because a lot of them are super similar to some of them is what we already done, and I'd rather just give y'all more time to practice. Okay, power of a power. Okay, the best part about this one, I feel like it's pretty obvious. It's not super hard to remember because what do parentheses tell you to do? Multiply, and guess what you do? No. Multiply. Goodness gracious. What am I writing? You just end up multiplying them. And I'm going to show you why. So if I have x cubed to the 4th power, then I have x cubed 4 times, right? And then I'm just multiplying x cubed 4 times, which means I'm adding 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, what's 3 times 4? 12. So it's the same thing. Okay? We don't want to write this out that many times. So it's the same thing as just multiplying. And the nice thing is parentheses tell you to multiply, so it's kind of telling you to multiply. It's kind of the same thing, too, as like distributing, because you have to give that exponent on the outside to everything on the inside. Every base on the inside. So this one has 2 bases. I have an x and a y, so that 3 has to go to both of them. So this 3, well, what's 3 times 2? And then 3 times 4? There's my new answer. Does that make sense? Now I'm in my own world. Okay, so now this one. Is the coefficient also a base?
No. Yes?
It actually is, yes. So I have to give the squared to the 3. So it becomes 3 squared to the x. So that becomes x squared over 4 squared. And then the y already has a squared. So what's 2 times 2? 4.
Oh, you're just adding.
Multiplying.
Oh, yeah.
I mean, 2 plus 2 and 2 times 2 are the same, so that's kind of confusing. Okay, and what's 3 squared?
What's 3 squared?
9. And what's 4 squared?
16.
And then this doesn't simplify, so there's my answer.
You have to simplify it?
If you can, yes. What?
How do you get the bottom one for first?
4 squared? Because I have to give that 2 to everything on the inside, to the 3, to the x, to the 4, and to the y squared.
You multiply 2 and 4?
I did 4 to the second power, 4 times 4. Are you talking about the 16 or the y to the 4th power? It's because there was a 2 already there. And then 2 times 2. Any questions with that? Okay, last rule is your negative exponent rule. Okay? Negative exponents mean it's on the wrong side of fraction. Okay, so if it's not already a fraction and there's a negative exponent, then you need to make it a fraction. So this is not already a fraction, so we need to make it a fraction. I'm not going to put anything on the bottom yet. But what has a negative exponent? The 5, the x, or both? The x. So I'm going to circle it as a negative exponent, and I'm going to draw an arrow to the opposite side of the fraction bar. And I'm going to rewrite it with a positive exponent and cross off the original. And I'm going to rewrite the whole thing. 5 over x to the 3rd power. And does that simplify? Nope, so that's my answer. See what I mean is when I say it's on the wrong side of the fraction bar, when I moved it to the bottom, it became a positive exponent. Yes? So on the front, we had that answer that was 1 over n to the 3rd power. Okay, but if we would have subtracted, we would have gotten n to the negative 3. Well, if we would have made it a fraction and moved it to the bottom, it would have become positive. And can we leave the top empty? No, so we would have had to put a 1. Does that make sense?
So, n to the negative 3rd power
Is 1 over n to the 3rd power.
so
However, you can't ever leave a negative exponent. Always have to fix a negative exponent. Okay, number 19, why do we like it? Huh? So we're kind of maybe.
Oh, no. Calculator.
There's no letters, so what can I type it in?
Your calculator.
The calculator. That's the best part about it, right? Okay, so I'm going to show you in the calculator, but I'm also going to show you by hand because I want you to understand it. So we do it to the negative 2 power. What do you think it equals?
16.
Well, yes, it does. Okay, it equals 16. Okay, and I'm going to show you the easiest way to do this by hand. Now, again, if it doesn't have letters, I want you to type in the calculator, but I'm showing you because I want you to understand why. Okay, so when there's a negative exponent, if I were to give the top and the bottom a negative, wouldn't they both have to move? Yeah, so it's just the same thing as flipping it. And then it becomes a positive 2. Well, what's 4 over 1? And what's 4 squared? There's your answer. Does that make sense? Okay, last one with negative exponents. Okay, so again, coefficients, numbers, we treat just like normal. So what is 40 divided by 20?
20?
No.
Oh,
2.
2.
Okay, and I'm going to circle, I always get rid of my negative exponents first. And the reason being is because negatives are way too easy to make simple mistakes with than to move them. So move negatives first before you start trying to combine them with anything, yes? So I'm going to move this one to the bottom, and it becomes m to the positive 1. I'm going to move this one to the top, and it becomes m to the positive 6. This one to the top, and it becomes n to the positive 9. And then the n on the n8 is already positive, so I'm just going to leave it.
Well, always, so when they're negative, you just put them on the opposite side?
40 divided by 20. What?
When they're negative?
You just move it to the opposite side of the fraction. Now, the 2 I've already simplified, so that's going to stay. Where are there, well, first off, what am I going to do with the m's?
Can you combine them?
How? What rule am I going to follow? What are they doing? Add, subtract, multiply, or divide?
Add.
Well, isn't this division?
So subtract.
So I'm going to subtract my exponents. So where are there more, top or bottom?
Top.
And what is 6 minus 1?
5.
Now, between the n's, is that addition, subtraction, multiplication, or division?
Addition?
That's what I'm going to do because it's multiplying, right? I'm going to add my exponents because they're multiplying. And what's 9 plus 8?
17.
Okay, I'm going to do just 2 of them on the bottom because I think they're good practice with a couple of mixed rules. And then I'm not going to do all 6. But I'm just going to do these very, very bottom 2. Okay, example 20 is a lot like example 19. This is the second example 20. Apparently I don't know how to count. But this one's a lot like the first example 19, the 1/4 to the negative 2 power, except now I threw in letters. So we're going to handle it the same way, except we can't type this one in the calculator. So the first thing we did there was, didn't we flip it to get rid of the negative? So we're going to do the same thing. We're going to flip it. To get rid of the negative. Now, there's 2 different steps you could go for here. You could distribute that to power over power, or you can simplify the inside first. And we're going to simplify the inside first. Technically, either way, as long as you don't make any mistakes, will be correct. But I think it's simpler to simplify first, and then you have less to distribute to. So we're going to handle our coefficients first, and we can do that in our calculator. 3 over negative 6 gives me negative 1 over 2. I'm going to leave that negative on the bottom with the 2 because it's on the bottom right now with the 6. Now, my y's are dividing, which means what am I going to do with my exponents? Subtract. And where are there more? The bottom. I have 5 on the bottom and 2 on top. And what's 5 minus 2?
3.
And what do I have left?
Z.
And where is it?
At the top.
And the squared on the outside. Do I have to have this 1 in front of my z? No. So I'm going to cancel it. And I'm going to give this squared to everything that's left. So I get z squared. What's negative 2 squared? Not negative 4. Positive 4. And then 2 times 3, 6.
Wait, why is it positive?
Because what's a negative times a negative?
But that's not negative 2, is it?
Negative 2?
I'll talk about the top.
The exponent's not negative. This is negative. The negative 2 on bottom.
So you did negative 2 times 2?
No. negative 2 times negative 2, because this is the same thing as saying negative 2 squared. I had to give the squared to the negative 2. Right? Because I was giving the squared to everything. I give the squared to the z.
Negative 2 times 2.
Negative 2 times negative 2.
Yeah, I understand.
You good? Right here? Because 3 over negative 6 gave me 1 over negative 2. And we just canceled the 1. You didn't have to put the 1. Okay, last one I'm going to do with y'all. We're going to first follow power to a power because we have to get rid of our parentheses before we can simplify. So I'm going to multiply 3 times 4, which is a to the 12th, 3 times 5, which is c to the 15th, and multiplication because parentheses means multiply. 2 times 2, c to the 4th, over 2 times 2, a to the 4th. Now I'm going to rewrite this, but I'm going to rewrite it proper in alphabetical order. So on top AC, so A12, C4, over, I'm going to flip-flop the bottom, A4, C15. So I have them lined up. Technically you don't have to do this, but it makes more sense. You could have just drawn your line across here. It's up to you.
But aren't you subtracting it?
We are. Because we're dividing, we're going to subtract our exponents. So where are there more A's? And what's 12 minus 4? And where are there more C's? And what's 15 minus 4? Okay, one more thing I'm going to talk about is on your practice. When you have a negative exponent and it's not already a fraction, what are you going to make it? Look at number 1 through 8. When you have a negative exponent, these are all calculator problems. Okay, and it's just so you can type them in your calculator and see the difference. That's all I want. Type them in the calculator the exact same way you see them. However, the only problem is they give you a decimal, 5 to the negative 3rd power. Okay, I don't want a decimal, I want a fraction, so what do? Math, enter. Or math 1, either way. Okay, so that's my first answer. Does that make sense? These should be fractions, not decimals. Yes? Okay.